In this video, I will continue to study the experimental Anim blueprint you can find in the game animation sample project. Anim blueprint that combines the state machine, blend stack, and choosers. And in this video, we will add motion matching to it. So there's a lot of things to do, and to keep things simple, we will implement the motion matching for the transition from walk to run. So this one. As you can see, the character the feet stays, in the same place. So the motion matching is used to synchronize those two animations. That way they blend smoothly. And for this, we need to add this toggle to the character class. We will also be adding a new custom movement mode that takes that into account. I also added some animations retargeted from the game animation sample project, created the motion matching schema and database for this character, and then modified the Anim blueprint. So we will be looking at all this, and as before, you can find the complete project file of my simplified character. The link is in the description. First, let's take a look how this toggle from walk to run is implemented in the sandbox character movement character in the game animation sample. So here in the event graph, you have the AI walk toggle, and when you press it, it will take this variable, walk to walk, and invert it and store it. So basically what it does, it stores this in the struct with other modifiers, and when you press Ctrl, it will just toggle the value of this bool. And it also takes the sprint into account, but we will not be looking at this here. Next thing, in the produce input, it will use this toggle and pass it to the mover. So here we have set members in as mover custom inputs. As you remember, you can pass your own custom strokes to the mover. And here, among other things, we give this gate, which is like a walk, run, or sprint. And also it takes sprint into account. It does different things. But the part that is important to us is here when it takes the wants to walk boolean and basically maps it to walk or to run, returns walk or run gate. So that's what we will be doing. And finally, if we look into character mover here, movement mode, we can see for the walking, it uses the PP my walking mode. So it's a custom walking mode. We will go now find it here in the blueprints movement modes folder. And as you can see, also it does a lot of things. First it does something, then it simply calls the parent function, simply walk. And what it does here, the part that concerns us, is this part. It will talk or gate, and with this select, it will set the max speed override variable of the movement mode. And this way, when the gate is, for example, walk, it will take this walk speed, which is something defined here. And for example, this one is 165 centimeters per second. That's the walking speed of the animation that we have for walk. So those variables can also be redefined here in character movement components. You can see them here. Walk speed and run speed. Those two numbers correspond to the two animations for walk and for run that we are using. Now let's look at our simple implementation of this mechanic. So first of all, we added the walk run toggle. So we added just a Boolean variable won't walk, and the toggle will change its value to the opposite. Then in the produce input function, we will set the member of our custom struct simply by looking at this variable, and we will be setting a run or walk. So this custom struct is something that also I added now. You can find it here. And as you can see, for now, it has only one entry. It is this enum, my gate, composed of two entries, walk and run. So those two things are new. We add the gate to the custom struct. Then we add to the custom struct to the collection. And as before, we return both structs inside the collection in the input command. Last thing we need to do is in the mover give here our custom walking mode that we created. It's similar to the other. We can redefine here the walk speed and run speed. Already see that there are not the same values because I also changed a little bit the animations. So if you go here, you can find my walking mode blueprint. In this walking mode, I just overridden one function, generate simple walk move, and the same as the game animation sample does. Second thing I do here is to call the super the parent function with all the same parameters. And the first thing I do here, I take the start state input. From there, I can find the input command. From here, I get data from collection, our struct, my inputs. From there, I take the gate and I set the max speed override for the mover. And then our mover, after that, will accelerate or decelerate the character accordingly. Next thing, we need some anims for walk and run. So I retargeted them from the anims for the character in the game animation sample project. And I also copied the tutorial character from the engine here because probably we'll need to modify it later. So we have those three animations. We use two actually, but for test I also took another one. Relaxed run loop forward and relaxed walk loop forward. When you retarget it, you get something like this. When you retarget it, make sure that you take the root motion too. And then you have various curves. Here I removed the footsteps because it's a dependency. Otherwise, it's more or less the same things. One other thing I removed because of the dependency is that here curve compression settings I put to default. It's similar to what they use, but just they use another class here. And then we have the retargeter, it did something to those curves, so I had to remove additional keys it added. Otherwise, it's exactly the same animation. And as you can see, there are some curves here. First of all, there's move data speed curve we will be using, and it's the literal speed of the character in centimeter per second. So as the retargeter will actually accelerate the character because it's bigger, we have to change here the speed. So for changing the speed, it's very simple. You go to the last frame, you check the time, then you look the root, and you look here how much root moved, and you divide this by time by 4.10, and you have your speed, which is here 201. And you do the same for the run animation. And the other curves we'll be using is the enable warping curve. This one is just can stay as it is, and the phase curve. Another thing you can find here is this pose search branch in Anim Notify, and this is the thing that allows us to use motion matching. So the config is pretty simple. We just link here the database. So what I did, I created a motion matching database and the motion matching schema you can find here. Now let's look at this motion matching database and motion matching schema. They are exactly the same settings that in the game animation sample project, so I will directly showing those. For first, we will create the motion matching schema, which is called actually pose search schema. And here, well, what we changed is that we changed the skeleton, of course. We took our skeleton. And sample rate 60, like the other. And then you have the channels. So that's the thing that the motion matching database will index. And here you can see that it uses curve channel 2 times. And the curve is the phase curve. And sample the phase curve at 0 and a little bit in the past. So what it means, if you look at the Anim, it means that we have this curve here, phase, which we can simplify. That's the result of the retargeting. So we can remove all those keys if you run the simplify filter. This curve, it's a little bit like the sync markers in the past. So if it goes between -1 and +1, the -1, as you can see here, is the left contact pose, when the left foot touches the ground. And the +1, you go here, is the right contact pose. So this seesaw curve goes up and down, and it's called phase, so it's like a walking phase, change of the pose phase. So with the schema says the database to index is the value of this curve. For example, let's say we are here. It says to index the value of this curve at this point and at a point a little bit back in time. And it will take those two numbers. So why it does this? That because, you know, if you like a sample thing here, you can find this point and also this point matches. But if you take this point and a point a little bit before this one, those two will not match those two, because those two is descending and ascending. And this way we can actually find exactly the same or the similar place in the graph without ambiguity. And as you can see, also we have this branch in also until here. So we can only arrive in this Anim, branching in, can arrive on the first two steps between here and here. So that's enough. Then we will use this schema and create the database. In the database, I also copied their settings, and the only thing I they changed this pause search mode. They set it to brute force. Not really sure why, but I copied it too. And finally, a very cool new feature that I like is that to populate the database, you simply need to reference it here. So in this post search branch in, you select your created database, and then, as you can see, the database will be automatically populated by all those three movements. So that's how we create our motion matching schema database and add it to the animations. Finally, let's take a look at the Anim blueprint. So first thing you need to add to the blueprint for the motion matching to work is the pose history node. And the pose history node, it takes a parameter called trajectory, which is the struct where it will store the pose history. Here we need to say sampling interval, how much poses it will store by second. So here we have 0, which means it will store everything, every frame. And then we need to say what we store. So here it stores a lot of things. And the curve phase, that's the thing we are interested in here. So actually, in some sense, it's not a pose history, it's a curve history. Then there are some other parameters. And the tag pose history, it will allow us to find this history later in the graph. Next thing, we need to actually perform the motion matching. And this motion matching will be performed in the setBlendStack from chooser function. So remember, that's the main function called by the logical Anim graph. We've seen that in the previous video. And here you have this call here, motion match. So as you remember, at this point, we already have a list of the valid suggested anims from the chooser. That can be just one anim. And so we call the motion match method. We give it the pose history tag here, the name of our pose history node. And that is enough for the system to find everything it needs. It returns us a pose search result when we find the anim and the time where we have to start playing. So we check if everything is okay. We cast the anim to animation asset, and finally we will here change the our blend stack input struct with this anim and the start time. And also another thing that is worth noting, that in chooser each output will have a flag saying that if this output want to use motion matching or not. So for our case, we have walk and run. We will annotate those anims with use motion matching, and then it will return the right anim according to our walking mode at the moment. Now let's look how it define it in the chooser itself. So here we have this evaluate chooser function. We open their chooser, and the chooser of the game animation sample project is very, very big. There is a lot of, sub choosers for different states, etc. Here we need to look, for example, we look into gate here. So if we are walking now, and if we are in the state machine state loop or locomotion loop or transition to loop, you go here. And here we also look, if we go forward, backwards, etc., we go here. And here you have the list of anims you can use in this state, in this when you fire this transition. So you have different parameters. And in this case, what we are interested in something like this: transition from run to walk. That it will use. It has an additional transition animation. We will not use this. We will directly transit from one to one, from one to another. But here it take this animation, check some parameters. What we are interested here the more is this. There is output struct where it says that it wants to use the motion matching. So we'll be remaking something, but much simpler. I want to add a side note here. Looking at all this, I start to think that the idea behind all this new system is to, in some sense, to push all the complexity into this chooser table. So if you think our blueprint is kind of pretty simple, there is a simple state machine, there is some simple chooser plus blend stack code, and then here in very organized, like a tree form, you can find all those different transitions and animations that the chooser will automatically choose for you, so that avoid all the spaghetti you had with the old Anim blueprints with the state machines, when you have to go from one state to another state to third state. And in here it's all extremely well organized and, you see, presented. Now let's return to our simple mover pawn and look how we implemented this. First, we have the chooser table myMover pawn mm. Here we have now 3 results: idle, walk, and run animations, and we choose them according to our state machine state, idle or walk, and our gate. So in case of idle, the gate is not important, so we can choose here any. And then in case we are moving, the state is walk. Unfortunately, I choose the same name, but it's the name of the state here. The state is walk, and we will look if we are walking or we are running, and choose this and this, or this. And so here is our output. I changed the struct from the default to my own output struct. So here we can say start time, and if we want to use motion matching or not. And that's it for this chooser table. Now in the Anim BP for our pawn, we will look at the gate. We will take the gate variable from our custom input struct, set it here. And before that, we will also record the previous gate into another variable. So that will allow us to detect when the gate changed. Once this is done, we can use it in the Anim graph. So first of all, before I forget, in the Anim graph, we added the pose history with this trajectory variable that we define it in the variables here. And then we collect the phase curve here. The other parameters I also took from their example. And I call it pose history here. Next, let's look in the logic state machine. Before it was just this. But here I added this state alias, which says that we can take this transition if we are in the move state. As you can see, it's like a loop, the transition from the move state to itself, which is a new thing, I think, in this version of Unreal. Before it wasn't possible. And if you look at this transition, it's very simple. It's literally looks if the gate and the previous gate are not equal, and then fire the transform. This other transitions is here because if you don't do this, if you don't check that the current state time of all this state machine is greater than 0, then this transition will be taken 3 times. Why this? Because here in our state machine node, we say that we can take the transitions 3 times. So normally it's useful for something else, like if you want to go somewhere and directly jump somewhere else. But here it will just call this thing 3 times. And that we don't want to do. So we add this condition here, exactly like in their project. I think probably they also use the max transition per frame the way it's supposed to be used. So otherwise we could just put 1 here. And so when we re-enter in this move state, we will be calling the onState entry walk function, which will call our setBlend stack anim from chooser, and it's here that everything happens. So we evaluate our chooser here. Now we receive the list of anims. In our case will be always 1, but you can have more anims. For example, you can differentiate from like if it's a walking start from left foot or from right foot, something like this. And our output. Here we have start time and the use motion matching flag. First we will set the anim for the blend stack here, the first one, and the start time. And then we will check if the motion matching flag is set. Then we will search for the matching anim in this list according to the pose history. And then if we found one, we will set this anim and the start time here. And then the blend stack will automatically play it. With this logic in place, if now I want to add more animations to my anim blueprint, I actually don't need anymore to match this part. All I need to do is to add the anims into my chooser table. And the chooser table will drive the anim blueprint. This way you can have more complex things without here adding the complexity in this graph. And finally, the last thing I did here is that inside the blend stack I added the dynamic play rate, which means if the character is not walking at the exact same speed as the animation, when it's accelerating or decelerating, this function will change the play rate of the blend stack input. So play the animation slower or faster. And it's also made the same way like in the game animation sample. So basically what we're doing here, we take the blend stack node that we identify here by the tag. We take the current animation and the current time, check if everything is defined. And then we take those curves, enable warping and move data speed we've seen in the animation before. This one serves as alpha, so if it's 0, the dynamic play rate will be just returning 1. And this is the actual speed of the character. For our loop animation, it's always constant, but if you can imagine also something that changes. And save it here. And then we will simply take our actual real velocity of the capsule in the world, divided it by the supposed speed, and this will give us the play rate modifier. So we'll apply this alpha, we clamp it a little bit and return it. And we will play the animation at this rate. And that's more or less everything we did for this. As you can see, now if I walk, if I press Ctrl here, I run, walk. So I think that's everything I wanted to tell for this tutorial. Thank you very much for watching. As I said before, you find all the files, the complete project you see here in the link in the description. See you.